So we're going to work an example practice problem that's a good practice for the Physics 355 final exam. And this is a problem involving force diagrams that combines a couple of different types of problems we've learned how to solve. So we're going to do, this is from the Walker textbook, Chapter 6, Problem 90, about a hockey puck. And in the picture you can see the puck is on a flat table going in a circle, and it's being pulled by a string, and then that string goes to the center of the circle, but it also goes through the table, and that same string is holding up another mass that's underneath the table. And so the goal of the problem is to find what speed must this hockey puck have if this mass underneath the table is to remain at rest. So I'm going to redraw the picture from a side view. So if you're looking from the side, that hockey puck is going in a circle, and it's actually, in my picture, it's at the left side of the circle, and it's going to be moving in a direction directly out of the paper, which I draw like that, and it's going to be accelerating towards the center since it's moving in a circle, which I draw like that. So here's where the hole in the table is. The other object is not moving, that's the goal, and also not accelerating. So, okay, so when we do our net force problems, we always want to make a force diagram for each object. So we're going to make a force diagram for the little mass, and then another one for the big mass, capital M. The little mass is sitting on a table, so we have to put normal force and little mg, and then that will have a string pulling it to the right, so that's a tension force. And we can see this matches up with our picture because there's a net force to the right caused by that string, and that's why it's accelerating towards the right, which is towards the center of the circle. For the big mass, we have mg, big mg, and we have tension from the other end of that string are the same.
And I think the problem said there's no friction with the table, so I didn't put any friction. Okay, we need to put our positive direction. So for the mass hanging underneath the table, because it's not accelerating, we can make positive any way we want. So I'm just going to make positive up for that guy. For the one that's on the table, we have to make positive with the acceleration, and it also has vertical forces, so I'm going to make two positive directions. So that'll be our y and x. Okay? So now we're going to do our net force equations. We're going to write, I'm just going to do the x equation for this mass on the table. So I would say net force external in the x direction is equal to T. That's the only force. So that's equal to the mass times the acceleration in the x direction. But since it's moving in a circle, that is also v squared over r, where r is the radius of that circle. I'll draw that up here. So that's our net force equation for that mass. For the other one, we have net force external is equal to T with a plus minus capital mg, which is capital M times his acceleration, but that's 0. So in this problem we've got two different masses and they're connected, so we know that the tension is the same pulling on both. And we have two different net force equations. So when we have two different equations and
we know that t is the same in both. We're just going to solve for t in this equation. T is equal to mg. And then we can sub that in to the other equation because it's the same tension. So I'll get capital Mg is equal to little m v squared over r. And the goal of the problem was to find the speed of the hockey puck. So we're almost done. We can solve for the speed v. We're going to multiply by r and then divide by little m, and I get capital M times g times the radius of the circle divided by little mass, and then I take the square root, and then I'm done. So hopefully this problem made sense. It's a good example of a practice problem, and good luck on all your exams.